So as you can see here, same idea. If they give us, well, this leg is 2, and I'm using the easier version of this, of course. This will be 2 root 3. This will be 2 times 2, which is 4. And so you give us one length of one leg, and we'll be able to find the rest without having to use SOHCAHTOA or anything else at all. And that's why you use those special right triangles. But then the question comes along as this. There's x in every single one of those leg lengths and hypotenuse lengths. Now the idea is, what if the hypotenuse is equal to 1? What if the length is equal to 1? What if the length of this hypotenuse for a 30, 60, 90 is equal to 1? Then what would be the lengths of this leg and that leg as well? So we go through and say, okay, well, I set up an equation. According to my given information, the length of the leg of a special right triangle is 2 times whatever x is. Well, in this case, the length is equal to 1. So I set 1 equal to 2x. And I solve for x. So that means that x is 1/2. Now that I know x is 1/2, guys, I can go back to here and plug in 1/2 in for x. And what we've done is we've found the leg lengths of a right triangle if the hypotenuse is 1 unit long or has a length of 1. So we come over, if the hypotenuse is 1, then the side opposite of 60 is going to be 1/2 times root 3 or root 3 over 2. The side opposite of 30 is going to be exactly what x is, which is 1/2. And so you're looking at a 30, 60, 90 triangle. The side opposite of 30, when the hypotenuse is 1, is 1/2. The side opposite of 60 is root 3 over 2. And the hypotenuse is 1, which we'll talk about in a moment. It's going to be a radius, but we'll get to that in just a minute. All right, it says, what if the value is 1 when the hypotenuse is, what's the value of b when the hypotenuse is 1? So now we're looking at a 45. So with 45, we've learned that it's x on bottom, and x root 2. We're going to do the same thing we just did on problem 1. You take the hypotenuse and set it equal to 1. And solve for x. Last class we learned you can't leave a square root as a denominator. That's irrational. And so we talked about how we take it out. So now, if the length of the hypotenuse of a 45-45 triangle is 1, that means the leg lengths are root 2 over 2. And it's the same for both of them because it's the same size angle. Root 2 over 2. I'll wait till you get caught up on that and then we'll go on to the next page. So let's keep those numbers in mind. 1/2, root 3 over 2, and root 2 over 2. 1/2, root 3 over 2, and root 2 over 2. Okay? Because basically, guys, when we talk about the unit circle, I'll be honest with you, those are the only 3 type of answers you're going to have unless we're talking about on the axis. Root 2 over 2, 1/2, or root 3 over 2. Those are the 3 values that we talk about. All right, let's go ahead and scroll on to the next part of this. So then we go through and say, okay, it says, looking at the 30, 60, 90 triangle, the circle below, using the length and height of the right triangle, what would be the coordinates of point P? Well, if this is a 30-degree angle here, on the previous page, we said the side opposite of it, what was the length of it? Well, no, this will be the angle. But what's the length of the side? If the 30, go back over to our triangle we just did on number 1. What did I say the length of the side of opposite of 30 is? We made it equal to a value. 1/2. Is it 1/2? Is the side opposite of 30 1/2? Opposite of 30 is 1/2. Look at problem number 1, guys. And that triangle, we had 30, 60, 90 triangle, right? We said that the hypotenuse is equal to 1. So the hypotenuse is equal to 1 length. The side opposite of 30, solved the equation and got 1/2. Therefore, what's the side adjacent to 30's length? Perfect. So it wants to know the coordinates of P. Well, how far do we go over along the x-axis to get to the point P? How far along the x-axis did we have to go in order to get to point P? Ignore the fact that there is a line here. How far did we go over? Root 3 over 2 is the distance we went over. How far did we go up? 1/2. So we're taking these values of the triangle, we're taking the values, the leg lengths of the triangle, and that's given us the coordinates of that particular point. Because what we're looking at, guys, and the title of this section is the unit circle. Unit means 1 unit. 1, whatever it might be. And that is the value or the length of our circle's radius. This circle goes all the way around, and if you notice, up here it's 1. So down here's another one, down here's 1 as well, and that's 1. But as we go along in the circle, there starts being, the radius will always be the same. The radius will always be 1. Which means every time I draw another triangle in here, if I draw another one over here, that will be 1. Over here, that's, well, I should have drawn out to there. But anyways, it was a horrible triangle, sorry. That will be 1. No matter what, because that is the radius. That's why they call it the unit circle. The reason why they call it the unit circle is because the radius will always be 1. Therefore, your coordinates will only have basically 3 types of values. 1/2, root 2 over 2, or root 3 over 2. And as you can see, guys, if I have the radius of 1 and I go up 30 degrees, if I start off here and I go 30 degrees up, once I stop at that point, root 3 over 2, comma 1/2 is going to be my coordinates. And he goes on to say, okay, use a trig ratios to find, or SOHCAHTOA to find the sine of 30. So in your calculator real quick, guys, find the sine of 30. Make sure your calculator's in degree mode. What'd you get? Would you agree with that? When you say 0.5, does that mean 1/2? Okay, I want you to find the cosine of 30, guys. Please. You're going to get some crazy decimal. Next, put square root of 3 divided by 2 and see if that equals it. And that's it. So the idea is this. I can now use a unit circle to help me find the answers to this. Sine of 30, sine of 60, sine of 45. Cosine of 30, cosine of 45, cosine of 60. These you can use tangent. We'll be able to use tangent as well. In order to find these special triangles, 30, 45, and 60, you'll be able to find that all the way through. What value, or where is 1/2? Is 1/2 the x or the y value of the point P? I'm going to put that on top. Can you go ahead and do that as well? Cosine, is it the x or y value for point P? The x. And that will always be true, guys. Sine will always be the y value. and cosine will be the x. And that's kind of what we had established here. Sine, y value, cosine, x value. And he goes on to say, what's the angle located at the origin? Well, what angle do we have there at the origin, guys? 30. So now let's go ahead and look what it would be like if it was 40, if it was 60. Different point of view now. What's our new leg that's adjacent to 60? What's the length of the leg adjacent to 60 in a unit triangle? Not yet. 1/2. Because remember, what was across from 30? What was across from 30? What is across from 30 is the same leg that is next to 60. So you guys are saying it because I said, hey, what's the other leg? You guys are blurting out 60 because you're giving me the other angle's measure. Which I wasn't asking that, but you're giving that answer. But if 60 is located across from 30, that means that 1/2 that we found is actually now located right next to 60. So this is 1/2, which tells you what is going to be the length of the side opposite of 60. There you go. Therefore, the coordinates of R is what? There you go. So with that in mind, guys, and what we just talked about with the x and y values being located, what is the sine of 60 degrees? Don't use your calculator this time. Root 3 over 2. Because the angle made 60 degrees, sine deals with the y value. Look at the coordinates. What's the y value of the point R, which is located 60 degrees above 60 degrees, which tells you, hey, that's how we found those leg lengths. The y value is root 3 over 2. So what's going to be the cosine of 60, guys? 1/2. Compare that to 30. How do those answers compare to each other? They're flipped. Sine of 30 is equal to cosine of 60. Put that out there. And vice versa. Because basically, guys, you're just changing the point of view, which means the leg lengths are the same length. Just however, it just means that, hey, what was opposite is now adjacent. What was sine is now cosine. You see how that works? Just that it flips that way. And that's, I wish in geometry they'd teach you that way, guys. Because what do you notice about both the lengths of these angles? What do they add up to? 90. And that's true for any two angles that add up to 90. Because you're about to see in a 45-45 will be the exact same thing too. All right. So let's scroll on to the next one. Do a 45. Guys, this intro stuff to unit circle might seem kind of boggy and you're like, I don't even know what you're talking about. Once we dive into it, it's all going to come together, okay? Right now, we're such a foundation of it, you can't really see the light at the end of the tunnel just yet. We're walking through together, but once we put it all together, you're going to start seeing this similarity stuff, okay? Just be patient. So this is going to be a 45-degree angle here. What did we say the side lengths of a special right triangle whose hypotenuse is 1, what do we say the side lengths were? Square root of 2 over 2.
So is this always going to be true?
Yes.
Like that's always
Yes, always. 45 will always have root 2 over 2, root 2 over 2. Which tells you the coordinates of P is... Perfect. Why is the x and y value exactly the same?
because they're the same thing.
They're both the same degrees. They're both 45 and 45. Good. Okay, can you tell me some other reason why? Maybe looking at the unit circle, the location of where we are in quadrant 1. We're right in the middle, aren't we? She said half, right? Yeah. But we're right in the middle of it. We're exactly in the middle of quadrant 1, which means that if you're in the middle of something, that means the distance from one side and the other side is exactly the same. And that's exactly what's happening here, is that we're right in the middle of quadrant 1, and the x and y values are exactly the same. I want the same distance over and the same distance up. So that's why it's root 2 over 2, comma root 2 over 2. And this kind of makes it easy on these questions, because find the sine of 45. Well, I don't care if it's y or x, because they're both the same. So the idea is, and I put kind of arrows on both sides of the equal sign, which means it can go both ways. Sine of 45 equals cosine of 45, or cosine of 45 equals sine of 45. I guess you don't really need arrows. But the idea is, these two still add up to 90, therefore they're equal to each other. 30, 60 add up to 90, therefore they're equal to each other, but that they're opposite signs, okay? And so it says, what do you notice about the cosine sine coordinates? They're same thing. They're both the x and y values. It's harder to see here because they're both the same. It's easier to see on the 30, 60, 90. Right, Ryan? Yeah. What's the relationship between cosine and sine coordinates for any angle and circle with a radius of 1? We'll repeat this one more time because it's going to kind of help you get through a lot of it. Sine is your y value. Yes, you already wrote this again, but I want you to write it one more time. Because here's the idea. If I give you an angle, you will be able to find the coordinates of that angle on the unit circle. And then I could go in and say, hey, what's the cosine of that angle? Oh, that's the x value. Hey, what's the sine of that angle? Oh, that's the y value of the coordinates I just know. And that's what it is about the unit circle, is that you're going to go in, find out all the coordinates around the unit circle, and then from there you can be able to find sine, cosine, and tangent. Without having to use a calculator, all you have to use is just the unit circle. All right, so here we go. Special circumstances, which there are always some in math, we know that. You know, it's what, in Algebra 1 you had, oh, linear functions, great, we had this y equals mx plus b, slope and y-intercept. All right, I got the concept of it, but hang on, there's also horizontal and vertical lines. Those have different equations. All right, same thing here. What happens if you land, if you notice these here, these land on an axis, don't they? These are called transversals. They basically land on an axis, so they land there. So that means that 90 degrees puts us right here. What's the coordinate of that particular point, guys, if this is a unit circle, which means that is a length of 1? What's the coordinate of A? 0, 1. What's the next one? 180? What's the coordinates of B then? If this length is 1. Close. Very close. Which direction are we going here? Negative 1, 0. There you go. What about C? 0, negative 1. And And then finally, D. Now D can be 0 degrees or 360 degrees. But what's the coordinates of these? 1, 0.
So you said you only meant like not like.
Yeah, so these are the ones that'll be, your answers won't be a root 2 over 2 or 1/2 or root 3 over 2. These answers will be 0 or negative or positive 1. Straightforward, because it's a unit circle. It only goes far out as 1 unit. That's it. And so that's why you see those coordinates on the extremes are right there. So now that you know the relationship between cosine and sine coordinates, let's go ahead and find the cosine of 90 degrees. Look at 90 degrees. Cosine deals with what values? X values. So what is the x coordinate at 90 degrees? Sine deals with what values? Y. So what is the y value at 90 degrees? 1. Cosine deals with x. What is the x coordinate at 180? Negative 1. What is the y coordinate at 180? What is the x coordinate at 270? What's the y coordinate at 270? All you're doing, guys, basically is knowing that sine is y and cosine is x and just picking that coordinate at this angle. Cosine is x. 360 puts us at the positive x-axis. What is the x coordinate at D? It's usually that part where the whole class jumps in and says the answer, but not today. What about the y coordinate? 0. Again, all we're doing is giving you a trig function and an angle. You're just telling me the x or y coordinate. That's all you're doing. All right, so let's go ahead and look at the first quadrant. The good thing about this unit circle, guys, is this right here. All you really need to know is the first quadrant. After that, it repeats itself. After that, the values repeat themselves, and all you got to worry about is it positive x or negative x? Positive y or negative y? It's going to be 1/2. Is it positive 1/2 or negative 1/2? Well, what quadrant am I in? I'm in the first quadrant. All right, so x values are positive, so it's positive 1/2. I'm in the second quadrant. All right, x values are negative in the second quadrant, so it's negative 1/2. That's all you got to do. You got to find the value and its sign. So we go through here. We say, okay, the first one is 0 degrees, or you can say 360 degrees, or it's 0 radians. And we just established what that coordinate is right there. What is the coordinates? If this is still 1, what's the coordinates of this point? 1, 0. We'll bump up to 30 degrees. What is 30 degrees in radians, guys? Pi over 6. Very good. We just established 30 degrees, what the x and y coordinate was at point P. Do y'all remember what that was? We'll flip back and look. What was the length of the side across from root 3 over 2, comma, what else? Bless you. Next angle up, 45 degrees, which is what in radians? Bless you. It is pi over 4. Bless you. And using our triangle we had earlier in the little exercise, what was the coordinates at pi over 4 or 45 degrees? The same on both, right? Because we discussed it being right in the middle. Next one up is going to be 60 degrees. Say that again. Yes, but not here yet. Let's talk about the radians first. But yes, you're right. What is 60 in radians? Close. Pi over 3. And now, what is the coordinates here, Sean?
Half and then
Yeah.
half.
Because you take these and do what?
You flip them.
You flip them. I said, what was the sine of one is a cosine of the other. So they just end up flipping. Then finally, the very last thing. 90 degrees, but which is what in radians? Pi over 2. Which we already established. What is the coordinates of this point? If this is the length of 1, what's the coordinate of the point that's at 90 degrees?
0, 1.
At this point, you say, okay, you got options here. Okay, and we'll talk about more options later on at first. But here's the thing. Some people, which I don't know why they would do this, but some people memorize this. Okay, they memorize this whole numbers and all that stuff as they go in. And memorization is okay at some extent to the point it's like, if you have to memorize this, the next time you need to find, if I need to take a problem that's a sine of 60, they will literally have to fill out all of this to find that value right there. Because they memorized it all, like how it all flows out. Okay? We're going to talk about some tricks along the way that helps you fill in that stuff and actually get you right to the answer you need. Okay? So let's go ahead and look what it all looks like filled out together. Okay? So that's one quadrant of it. So here's the deal, guys. You're going to see these values right here flipped and turn negative or positive. That's it. These values will be the same. It will be the same numbers, but you just start seeing some of them be positive, some be negative, and some of them be in a little opposite direction. You'll see why in just a moment, okay? All right, so let's go ahead and get into filling in one unit circle. All right, this ain't going to fit, is it? I'm going to have to... That's going to have to work. So let's go ahead. We've already filled in the first quadrant. So 0, 360, or 0 pi, or 2 pi. We said it was 1, 0. Over here we said it's going to be 30 degrees, or pi over 6. So we end up saying that is going to be, what? 1/2 and root 3 over 2? Or the other way around, right? 45, which is pi over 4. These are... Do what?
Is it pi over 4?
Pi over 4. Should be pi over 4. These are the same. It's root 2 over 2. 60, or pi over 3, which is the flip of pi over 6. And of course, to finish it off with 90, what we've already done. Oops. All right, first quadrant's done. So now let's go ahead and take these values and use these values as we're going back down. Now remember, all the while, we are going to talk about a reference angle. All the while we're going to talk about its reference angle. Because 30 degrees will have the exact same value. I did this exercise with you guys last class. I said find the sine of 30. Find the sine of 120. Find the sine of 210. Find the sine of 330. And you all got the exact same value. Because they had the exact same reference angle. And that's exactly what you're about to see here. Guys, what would be the reference angle for this first line here? 60. Because I got to go 60 degrees to come back down. Remember, each one of these lines are going to be 30, 45, or 60, right? So, I'm not going to write 60 here. I'm actually going to write what the value is. This ends up being 120. And just follow me along with this, guys, as we fill along, okay? Or 2 pi over 3. The reference angle is 60, so the values is the same as 60 degrees. 1/2 root 3 over 2. 1/2 root 3 over 2. They follow the exact same values. One little small difference. In the second quadrant,
Multiply by 2.
no, we don't do that yet. We won't do that. What values, is there certain values that are negative in the second quadrant? What x-axis here is what?
It's negative 1.
It's negative. So all we need to do is, I don't have enough room, but make it negative 1/2. Then we go again. This is 135. Or 3 pi over 4. Again, follows the same value as its reference angle, except the x value is negative. $150 is the next one. Or 5 pi over 6.
Why would we jump from 3 to 1?
And again, it follows the same value as, because what's the reference angle of 150 degrees, guys? How many degrees do I need to go to get down here? 30. So it follows the 30 degrees. What I'm going to do here, guys, is in another color, I'm going to write out what the reference angle is. That way you can see the connection from, 30 degrees, that matches the exact same coordinates where 30 degrees is. Because all goes back to quadrant 1. Finish off the second quadrant. $180, or just pi. And of course, we talked about it earlier, negative 1, 0. So as you can see, guys, going around with the coordinates, it's the same values of the reference angle, just their signs change. Either x is negative or y is negative, because it depends on what quadrant we're in. We're in quadrant 3 now, guys. So what's going to be negative here? X and y, isn't it? And I guess I should have filled this out. I did not notice this. At the upper left, the very upper left, positive and negative. Positive is y values, or better known as sine now. Negative is x values, or cosine. In the third quadrant, there's nothing that's positive, is it? So the x, you know what, I'm not going to write x. We're just going to go ahead and start writing cosine. Cosine and sine are negative. In the fourth quadrant, what's positive? X, which deals with what trig function? Y's are negative, which means sine is negative. All right. Keep going around. The next one is 210, which is 7 pi over 6. Reference angle of 210 is what, guys? So the coordinates are what? What's the coordinates for 30 degrees, guys?
Root 3 over 2. But then there was negative.
Yep. Root 3 over 2 and 1/2, in which we're in the third quadrant, so both of them are negative. 225 is our next angle. What's a reference angle for 225 degrees? We'll follow pattern. What's always in the middle? 45. Oh, this will be 5 pi over 4. What were the coordinates of 45 degrees? And Sean went ahead and said negative in both of them because we're in the third quadrant. Next one, 240 degrees. What do you think the reference angle is here, guys? That's the coordinates, you're right. What's the reference angle? 60. The radians here is 4 pi over 3. Just what Johnny said. 1/2 root 3 over 2. Both are negative. Almost done, guys. Almost done. All right, so we got down below, which is 270 degrees, which is 3 pi over 2, 0, negative 1. 3 more left, guys. All right, so we go into here. Fourth quadrant, 330 degrees. What is the reference angle for 330 degrees? 60. Good. No, I'm sorry. Yeah. Sorry, guys. Hope you have a pencil. It's 300. I'm getting ready to be all the way to the end. My bad. Which is 60. This radian is 5. Nope, don't want red. 5 pi over 3. What are the coordinates of 60 degrees, guys? What are the coordinates for 60 degrees? We're in the fourth quadrant, so what value is going to be negative? Sine, or y. Good. Next is 315. What's the reference angle for 315? Seven pi over 4 is its radians measurements. And we know with 45 degrees it's always going to be the same. Except again, we're in the fourth quadrant, so what values are negative here? The y. Last one. This one's 330 degrees. What is the radians is 7 pi over 4. 330 degrees. What's the reference angle of 330 degrees, guys? 30. The radians for this is 11 pi over 6. What are the coordinates for 30 degrees? Okay. So, yeah, put the pencil down, rest. You burned it.